You've probably heard the old saying that two heads are better than one, right? Well, in the world of machine learning, it turns out that hundreds or even thousands of decision makers are way, way better. Today, we're going to demystify one of the most powerful algorithms out there, random forest. So let's dive in and see why, when it comes to data, a whole forest is just so much smarter than a single tree.
I mean, just think about that for a second. If you're only relying on one single perspective, one point of view, how much are you actually missing? How biased is your final decision going to be? It's a really fundamental question, not just for us, but for the very algorithms we build to make sense of this incredibly complex world.
And that's really the core idea we're going to unpack here. When the data is messy, when the problem is complex, and the stakes are super high, one perspective just isn't going to cut it. You need the collective wisdom, the diversity, and the raw strength of an entire forest of perspectives. Okay, so to really get why a forest is so powerful, we have to start by understanding the problem with a single decision tree. Don't get me wrong, they're great tools, but they have one major, critical weakness. And that weakness has a name: overfitting. Here's an easy way to think about it. Imagine you're studying for a test, but instead of learning the concepts, you just memorize the exact answers to the practice questions. You'd kill the practice test, right? But you'd almost certainly fail the real exam. A single decision tree can do the exact same thing. It gets so obsessed with the training data that it ends up memorizing all the noise and random junk instead of the real underlying pattern. And this really highlights the fundamental mismatch. On one hand, you have a single tree, which is just desperate to memorize every little detail. On the other hand, you have real-world data, which is noisy, complex, and full of hidden connections. It makes a single tree really unstable. A tiny change in the data can create a completely different tree and spit out totally different predictions. Not great.
So, what's the fix? How do we solve this? Well, if one tree is the problem, we build a forest. And this is where the random forest algorithm comes in. And honestly, it's such an elegant and beautiful solution to that whole overfitting problem. The solution is actually kind of simple when you think about it. Random forest doesn't just build one tree, it builds a whole committee of them, an entire ensemble, and then it just lets them all vote on the final answer. This whole process of combining a bunch of models to make one supermodel, that's called ensemble learning. And this quote just nails it. The whole idea is that if you get a big group of slightly different trees, each with its own unique viewpoint, and then you average out all their predictions, you start to cancel out all the individual mistakes and noise. The collective decision becomes so much more accurate and reliable than any single tree could ever be on its own. So you're probably wondering, okay, how do you actually grow one of these digital forests? Well, it all boils down to two key ingredients that make sure every single tree is a little bit different: randomness and a whole lot of repetition. Let's just walk through it. First, the algorithm grabs a random sample of your data. This is called bootstrap sampling. Then, and this is the clever part, at each decision point in the tree, it only looks at a random handful of features. This forces each tree to learn different patterns. You just repeat this process, say, hundreds of times, building all these unique trees. And then, at the end, to make a prediction, you just count the votes from all the trees. It's simple, but man, is it powerful.
All right, so we know how it's built. But what are the actual concrete advantages of doing things this way? Why is this collective intelligence thing so much more powerful in the real world?
Well, the number one absolute biggest advantage is its incredible resistance to overfitting. Because we're averaging the predictions of all these different trees, the model doesn't get hung up on the noise from any one sample. It's forced to find the true signal hiding in the data, which makes it way more reliable when you show it brand new information. And here's another huge strength. Since every tree is looking at a different random mix of features, the forest as a whole can uncover these really complex relationships between variables, the kinds of interactions that a single, rigid tree would completely miss. It's like having a whole team of detectives looking at the same case from different angles. They're going to see things an individual just can't. And the benefits just keep coming. Random forests are known for delivering super high accuracy. They're incredibly robust. A bit of noise or a few weird outliers in the data won't throw them off. They can handle massive data sets, and they even give you a more stable, more reliable sense of which features are actually important for making predictions. It's the whole package. Now, this isn't just some cool concept from a textbook.
Random forest is a total workhorse algorithm. It's being used right now across tons of industries to solve real, high-stakes problems.
I mean, just think about the applications here. In the world of finance, it's hunting down fraudulent transactions in real time. Retail companies use it to understand exactly what their customers want. In healthcare, it can help figure out which patients are at high risk for diseases. It's just incredibly versatile.
And if you look at where it's being used, the numbers really tell the story. Finance, healthcare, and retail are huge adopters. We're talking about industries that rely on the accuracy and stability of random forest to make critical, data-driven decisions every single day.
But, and this is an important but, like any really powerful tool, it's not perfect. To use it right, you have to understand the trade-offs, you've got to know its limits, you have to know how to properly care for your forest.
So here are the main things to watch out for. Building hundreds of trees, that takes time and serious computing power. And while the forest's final decision is super accurate, trying to figure out exactly why it made that decision can be tough. It can feel like a black box. And all that complexity means it needs more memory and can sometimes be slower than simpler models.
So at the end of the day, random forest is just this beautiful demonstration of collective intelligence. By combining lots of simple, slightly flawed perspectives, we end up with this incredibly powerful, robust, and accurate tool. And that leaves us with one final thought to chew on. If we can build a forest of algorithms to tackle problems like financial fraud or predicting disease, what's the next big, complex global challenge we should point it at?